And what we are going to learn today is a very detailed discussion about the HDFS. Right, so we'll learn what exactly is the HDFS, how it works, what are the different components in it, how does it stores the data, where exactly it stores the metadata, and all the details about it. Okay, and also we'll look into the yarn. So we had a brief introduction, like yarn is it's uh, it's one of the component of the Hadoop, which takes care of all the resource allocation and the way the data is getting processed. Right, so those are the two important topics that we are going to cover today. Right, so let's quickly get started with what is HDFS and what exactly we have, like what are the different components in it and all. So the need for the HDFS is it's we need a very cost effective solution for storing huge amount of the data. Right, so whenever the cost factor comes in, we always look for, I want the maximum performance with the minimum cost, and HDFS is that alternative which gives us the best solution in the minimum cost, and the cost is down because the hardware is not that expensive. Okay, and second thing is also it is reliable, and it is it gives us the speed also because we are able to process the data fast by distributing them across multiple nodes. Right, so that's the need for the HDFS. And then we learned yesterday that a regular file system, the block size is only a few kilobytes, whereas if we compare that with HDFS, so HDFS has a very larger block size. And the advantage of having a larger block size is, if we have a larger block size, we can read a higher amount of the data, huge amount of the data in one go. Right, so read, write, and the disk IO, the time which we spend to find out where the blocks are located and all of that, so those time is getting reduced if we can increase the block size. So if you compare, like, this is 128 MB is the default block size in Hadoop 2. Okay, so 2 is the latest version. So in Hadoop 2, the default block size of HDFS is 128 MB. Okay, so and these are the characteristics. HDFS provides a very high fault tolerance. It has a very high throughput, and HDFS is very economical. So yesterday we covered till here. Today we'll continue with a deeper dive into the HDFS. How exactly is the data getting stored? What are the different components in it? Now, if you look into this diagram, we have something known as a name node. Okay, and then there are multiple nodes which we call them as the data nodes. So it's kind of a master slave architecture. Name node stores the metadata, and the actual data will be stored in the data nodes. Right, so if you look over here, the node A, B, C, D, these are the data nodes, and there is a bigger server, kind of a master, which stores all the metadata. Like, what is a metadata? Can anybody tell me what do you mean by metadata?
The data about the
Data
data.
of the data in the data.
Data about data.
Absolutely. Perfect. So data about the data means the information about the data, right? So let's say I have files. So what is the data about the data? I want to know where exactly these files are located, how many blocks it has, right? Where exactly the replicas are present. So all this information will be stored in the name node, and the actual physical data, the data blocks, will be put on these slaves. We can call them as the data nodes, right? So the term like data nodes, worker nodes, slave nodes, all of these terms, they are all used for this components which actually stores the data. Okay, now if you look over here, if you have a very large file, the first step is I need to break down into smaller pieces, and that's nothing but the HDFS blocks. Right, so 128, we are going to break down a larger file into smaller pieces of 128 megabytes, And then the next step is I'm going to distribute those chunks of the data across all the nodes that we have, right? So for example, if I have a file which is having 4 blocks, so b1, b2, b3, and b4, what I'm going to do, I'm going to store the b1, b2, b3, b4 across multiple data nodes, and also I need to replicate it. So for example, the b1 is over here. If you see, the b1 is over here, and we have another copy of the b1 present in node number d as well, right? Similarly, for the b2 as well, we have b2 over here, and we have another copy present somewhere else also, like over somewhere else also, right? So this way what we are doing is, over here we have another b2, right? So we are splitting up a bigger file into smaller chunks of the data, distributing it, replicating it, and all of this we are doing so that even if some of the nodes fail, we can read from the replica which is present on some another node. Okay, so if we have to draw an analogy, the way it looks like, let's say I got a huge amount of the collection from somebody, so a librarian got a huge amount of collection of the books. Now what he will do, he will put all the unique copies, like all uh, kind of what are different copies I have in a small rack, which would say like these are the different books which is present in the library, and the multiple copies would be put in the racks. Let's say it will be distributed among multiple racks, right? So over here it's kind of an index. If you directly go to the library and you go and check this cell, you will come to know like these are the different types of the book which I have in the library. And if you want multiple copies, you can go to the another cell, you can pick the copies from there. So this one is kind of a metadata, right, which tells you what are the things I have in my library, and the actual data I need to go and pick from the specific racks, right? So that's how HDFS also works.